Hi, this is Brian McHenry of McHenry Software. We're going to demonstrate here as a quick illustration of some of the changes we've made to improve the automatic iteration optimization option SMACITER of SMAC3D. And we're going to do it with a full-scale test, just since the truth is what we like working with. And then obviously in your particular cases, you were trying to match evidence. In this one we had where they measured the approximate impact location and the rest positions and then the damage to the two vehicles. That's generally what you need to use this program. To put it in, we basically click on the target to click on targets, and you notice this already has them in there, because see, if I click on rest position of vehicle 1, see how that moves around. We can obviously make this prettier, but for right now it's functional. And you have the other most important thing is to make sure you put in damage, because damage gives at least approximation of damage of where on the vehicle is the damage and what's the approximate extent of the damage, because that's one of the things SMAC does that other programs can't do, is it not only predicts the trajectory of the vehicles, but it also predicts the damage based upon the impact configuration and at every millisecond during the collision. It calculates the forces and predicts the damage. You all probably know that. Sorry to repeat that, but that's a very important factor to make sure you get approximate location and extensive damage on each of the vehicles. We see we have the vehicles at 25 each, approximate. If you use momentum or something, it may give you a number, and this is to test and refine those numbers. So now we go ahead and we can click on bring up the side item with the iteration. We're going to run this in 2D just to make it quicker. It takes about 10 to 20 seconds per iteration, 40 iterations for 2D. It takes about 90 seconds, and I just want to get this over with quickly, but you can do it in 3D or 2D. So in 3D, you have two options. The only thing you really need to look at is option 1 or option 4. Option 4 is to load the last best, but we're just going to, since we're starting from scratch here, notice we've got a 1214 error. Some of the things to look at here, your starting values, and then the last values, which you haven't changed, varying amounts. If you don't want to iterate on one of these, you basically change that to a 0 for any of them. Like if you didn't want to change the X or the Y, if something definite of the impact, or if you wanted to keep a velocity fixed and see what's the best match you could have, you set that varying amount to 0. Other thing is for steer option. Generally in accidents, if they run out to rest, there may be either steer induced by damage or steer induced by the steering system reaction. And so this does an automatic iteration so that you're not trying to match a long trajectory by a steer angle, or without steer angle by the collision itself. Over here is where it lists what the steer angle is, and down here when this runs, and I'm going to not speak while it runs, and I'm going to speed it up just because even though it's only going to take about 60 seconds, why not do it in 10 seconds? So we'll go ahead and we run without pause. There's pre-impact tests and other things, but I'd probably stay away from those for now because we're still tinkering with those. Let's go ahead and run without pause. There's our summary of the runs, and one thing I want to note is on this other one down in the lower right corner here, you could barely see it, is where the actual steer, and you could see when it says steer iteration, you could have seen the steer changing, but we'll show that a little later. I'll move it up into a point where you can see it. But you notice here it tells you how many runs were run for each of the iteration steps, so loops of 5, and then 12 seconds, 17 seconds, 18, 17, 18. So now we go ahead and exit. We got about a 215. But let's go ahead and rerun this with the best of show to make sure that that's what that 215 is what we've got. So we click on 4 and we say run. And you see it's down to actually 161. Sometimes it's supposed to run the best of show. I'll look into that to make sure that that last one it shows is the best. But just rerun it with 4 and that tells you. So let's go ahead and grab the screen because we're going to use it to compare when we reload these best of show. So we exit. Now if we go to the view menu, well first let's look at the trajectory. It's not bad. We could run this more because generally you try to get down to 150, maybe 100, something like that. and get better matches. That's basically you want to do is the best match. But we go ahead and we go to the view output files, and then SMACITER, third one down, and make sure you click on simple view. If yours isn't selected, then I think we've made it so the default is simple, because that loads everything super fast in 3D graphics. Go to run summary, and you see at the beginning here, the following are the inputs which will produce the SMACITER results, and that's -1 and +1 and -1 for the steer for vehicle 1 and 2, and then these are the inputs that are on the cards 2 and 3. We're going to go ahead and grab this all, because then we can go ahead and compare all the information that's in our run summary. Obviously, if you have two screens, you could keep it on another screen. I'm going to just go ahead and throw it in a program called TextPad. But obviously Notepad, other ones, but you see now I have that, and I can then compare to see how we compare with all the measurements and etc. that are in this output file from the beginning file. Now, what I generally do is say, let's go ahead and we close this. We could go in right now and edit this file and change it, but then we never know where we started, and sometimes you're taking, hey, this is my inputs, and what were they? So I would say I'd go ahead and go out to the button there, or in grid mode, it's the edit file. Well, actually, let me just show you what it is on grid mode. Before we do that, we just click on it, and we click a plus, and then we're just going to call this Ricsac6 without the iter after it. So this is the one to show you. This is the best of show Ricsac6. So we click on that and make it the default, close. Let me just click out here. One of the things from grid, if you start from 3D grid, which then every time you run the graphics, it doesn't take as much time to load, but you can always go out to grid for all of those familiar with grid. You just click on grid. Click into grid, and now the place where we get that is you switch msmac file. See, it has the same function. And we're just going to leave it at that. And then you can do anything that you're used to doing in here. You can go ahead and all these menus work, everything works. But then every time when you want to run something, you just go back to graphics. And it saves it. If there's any changes you made, it'll say, do you want to save before you go to graphics? It saves it, and then you can always check in the input editor here. But so before we do this, we're going to move this down a little and bring over our list. And of course, I've got a much smaller screen than I have because I'm doing a screen capture on this, and YouTube doesn't like too much. But you see how now I've got the cards right there. So if I go click on this, or from grid mode, I can do this. But first thing, we have -7. You notice this number here. I can actually put this line right to it. So there's the numbers we want here. -7.301, 1.707. And you can round those off. I mean, it may make a slight change, but hopefully not a dramatic change. 22.207. Then we're going to move down a line. 15.039. And then remember, we have +1 and -1 for the steer. So the steer for vehicle 1, which is on card 10-2, notice how it says there, table 10, sequence 2, is 0. So we're going to change that to a 1. And you can try this with and without the steer if you want, or you turn off the steer iteration if you don't want to have to put in any steer. But a lot of times you'll force it to use a lot more speed to get to a position of rest or change the moments, etc. So it makes it more difficult. You want everything to have as many possibilities. So now we go ahead and we save this. We say OK. And then it goes ahead and runs it. You couldn't deselect that and not run it. But now when we run it, and now just to double check to compare, we go to the output. And again, that file name was Ricsac6 and the run summary. And if we look at, main thing, position of rest, let's go get our text pad over here. The position of rest, and let's move this up a little here and bring him in here. There's the end of run. Oops, guess I gotta bring this up a little more. Problem with using a smaller screen. Apologies for the having to run around here. See, we're at 59, 58.32, 58.38, 15.09, 15.09, 15.11, 16.51. There's a minor variation, 16.28, 16.3. Delta V is 11.14, 17.10, and here it's 11.1, 17.09. So they're very close. And it's a demonstration of how you take your best of show, and now we basically, the only other thing you could do is if you have your targets, and you generally want targets, and so really this is just a single run that then you can simulate and view from other angles. And of course you can turn those targets off. Now that you have a diagram, you would probably have an overhead, etc., and you can if you click on this, you can say hide, and see they're gone now, and so now we can just look at the actual trajectory. That's just one of the quick changes, fixes we have so that you can easily go from your best of show, from an iteration optimization to a single run. That helps, and please let us know if you have any questions, and thank you for watching.